Hello friends, I am here to explain the design of machine element 2 subject, and welcome to my channel Make Maharashtra. So last lecture we have seen the one numerical which based on the force analysis, correct. So I told you the procedure how to solve. Another important numerical I am going to solve in front of you here. So please see the procedure and try to solve from your side. While giving the numerical or solving the numerical, you should sit with the calculators, pen, pencil and etc. So see this numerical, I hope you are able to solve with me by taking the reference of previous session. So I'll read the numerical. A pair of worm gear designated, this will be the designation. First digit indicate number of teeth on worm, second digit number of teeth on gear, third one is a diametral quotient, fourth one is a module. Transmit 10 kilowatt power. I have mentioned the power 10 kilowatt power. Of course, worm gear transmit, so input power is 10 kilowatt at 720 rpm. So this will be the rpm of worm supplied to the worm shaft. This is for worm, that's why NW and PI is taken. The coefficient of friction is 0.04 and pressure angle 20 degree. So mu is 0.4, pressure angle 20 degree. Assume the worm gear is above the worm gear and rotate clockwise direction when it is viewed from left, clockwise direction, and when it is viewed from left, and of course it is having left hand both. Determine, of course, component of the forces, 3 component, radial, tangential, axial, 3 of worm, 3 of gear, that will be 6 component. Now second will be the efficiency. So first of all, write the given data, which is very important, which gives you the idea what they are asking. Now I'll start with the component of the forces. Before the start, I told you the step number 1 is always related to the terminology points, which are the terminologies. So such as dw, diameter of worm, m into q, so 4 into 10, so dg, m into zg, 4 into 52, that will be the basic dimension. This after that we'll have to calculate lead angle, tan of lambda, zw by q. Zw is known, that is 2 by 10, so therefore lambda is equal to 11.31 degree. Pitch line velocity of worm, pi dn by 60, rpm is given, that's why it is in meter per second 1.50. Next point will be the friction angle, tan of phi v is equal to mu v. Mu v is nothing but mu by cos phi, so mu is 0.04 and cos phi is 20 degree. So we'll get the phi v pressure angle, friction angle 2.43. Now we'll start with the force. First of all, we need to calculate tangential force. Fwt is equal to input power divided by velocity. Input power 10 kilowatt, velocity we have calculated. Through that we'll get the value which is equal to axial force of gear, that is 6631.7. The 2 force at a time we got. Second is axial force on worm. See here, we are here calculating worm only, because remaining worm gear automatically it will come by the balancing of the forces, equal and opposite forces. So you can see axial force is equal to Fwa is equal to Fwt divided by tan of phi v plus lambda. Just put this value which we have calculated. We'll get the axial force 27.10 10 raised to 3 Newton, which is equal to tangential force of the gear, Fgt. Clear? Next will be the remain radial force. Radial force, we know the equation, that is Fwr is equal to Fwt into tan of lambda divided by tan of phi v plus tan of lambda, tan of phi n divided by sine of gamma. So this will be the all the values we kept here. We'll get the radial force acting on a worm, which is equal to radial force acting on a gear. According to diagram, they have suggested it is a left hand thread and rotation is a clockwise. So therefore we can draw this tangential force which oppose, in previous session I told you, which oppose the rotation of the worm. So Fwt is that the right side towards the right side, and opposite to that Fga. Same gr opposite to each other, it means toward the center of respective worm and gear, and axial force is opposite to the tangential force of gear, correct. So likewise we need to draw the diagram. If possible, you can put the values in front of this diagram respective gear respective gear force, you can write the values. Next they have asked for the efficiency, you can just put the value. Efficiency equation we know, it will comes up to 81.75%. Third point, third point, previously we have calculated power loss. Right now they have not asked, so no need to go for, only two parameter we need to calculate, correct. So students, I am here explained all the procedure, all the requirement for the force analysis while solving in the, you can see the step number 1 is always terminology, step number 2 will be the force analysis, and step number 3 will be the efficiency. So same thing will have to perform. Such kind of numerical will be asked for 6 mark, so you must aware about this. Clear? 2 examples I had explained, I have explained from my side. So now this will be the example you take as a homework. So just take a screenshot of it and try to solve and upload the PDF of this numerical on Google Classroom, so that I can get idea that you are solving or not, correct. And do solve, because right now we are not having face to face lectures, communication, chalk and talk. Benefit of this, and don't waste the time. Okay, clear? So take the printout of this and try to solve from your side and upload the PDF on Google Classroom. Thank you.